Hey everyone, Chang here and welcome to my channel. Now for today's video, it's not going to be any new topic in any way, shape or form. I thought it'd be a good idea to basically introduce or at least show you guys several standard test questions. Now, the theme or the focus of this is basically functions. So I guess the best way to use this video is test yourself. Every time I introduce a problem, maybe pause the video, see if you can solve it before I go over it. There's going to be 6 questions. Each and every one of them are related to function, but they count on your understanding of different segments or different components of function. So let's begin. So here's our first question. Which one are functions? You have f of x equals 4x squared plus 3. You have g of x equals 5 and h of x equals this set. Basically, it contains individual points of 2, 2, 2, 1, and 4, 5. So, which one are functions? Got it? Cool. Basically, as you guys can guess, this is just testing your definitions of function, whether you truly understand functions or not, right? The concept of function or the key of function is that for every input, there's exactly one output. It might end up being the same output with different inputs, but you can't have one input and produce multiple output. So for this one, it's fairly simple. Every time you put in x, which is going to be plugged in right here, you get exactly one number, right? There's no if, ands, or buts, right? That's exactly one number. So this, by definition, is a function, right? The second one, g of x equals 5. Once again, if you put in any number, guess what? The final outcome is just 5, which is fine because it's exactly one outcome, which is going to be 5. So this is also a function. So in a test-taking environment, most likely, not always, so it's always safe to double check, but most likely after you've cleared out all the other possibilities, there's probably going to be 1 or 2 that are not, right? So in this case, this is it, this is it. It could be that this is it. It might not be. So best thing to do is just check. Here we have h of x. Once again, remember, one input, one output. So you have 2, 2. That means if you put in 2, you get 2. Great. If you put in 2, you get 1. Okay. If you put in 4, you get 5. Okay. So notice something. If you put in 2 and you get 2, and you put in 2, you get 1. Well, if that's the case, if I put in 2 here, which one am I getting? Am I getting 2 or 1? You see, that's the key. So this one, it had multiple output for a single input. In this case would be 2, right? So this is not a function. And just like that, that is the first problem. All right, so for our next problem, we have this one. Given f of x equals 3x minus 2 and g of x equals x squared plus 4, this, right, f of g of x equals g of f of x, is it true or false? So go ahead. Got it? Cool. So this one is just testing your understanding of basically, I guess you could say, compound function, right? I think that's the appropriate word. But basically, what is f of g of x and g of f of x? When you see a notation like this, it's basically asking you to plug one into the other. In this case, whatever's closest to x goes in, and then it goes out further and further. So, for example, if we're talking about f of g of x, let's just talk about this one right here. We got to look at g of x first. G of x equals x squared plus 4. So what you're going to do is you're going to get x squared plus 4, and in place of where x is for f of x, right, you're going to actually plug this whole thing in. So in this case, here we have f of g of x. We're going to get 3, right? I'm looking at f of x right here, and instead of x, I'm putting a whole thing of x squared plus 4, which was originally your g of x, right? And then minus 2. That's this guy right here. Now, this second part, g of f of x, it's the opposite. Now, we're going to look at f of x, and then we're going to get this guy, and we're going to plug it into g of x. So in this case, what do we get? We get, instead of x squared, we get 3x minus 2, this whole thing, squared plus 4. Now the question itself is asking, is this equal to this? Now, without doing a lot of computation, you can sort of see that no, there's no way it is. But if you want, you can always simplify it out and see what we get. We get 3x squared plus 12 minus 2, which is basically 3x squared plus 10. Okay, cool. This one is different. you have 3x minus 2 times 3x minus 2, then add 4. Well, if we FOIL this out, basically, what do we get? We get 9x squared minus 6x minus 6x plus 4 plus 4. Now, without simplifying further, clearly these two are not equal in any way, shape, or form. Just looking at this, we have a 3x squared, whereas this one we have a 9x squared. So, false. Alright, so this next one right here is a pretty simple one, a pretty fun one. Right? We have h of x equals 4x minus 6. Now we have h of a equals 0. What is a? You guys got it? Cool. So, this is playing on the definition of functions again, but it's taking it one step further. So here we have h of x equals 4x minus 6, okay? Here we have a, right? So what we're going to do is we're going to put a in place of where x is. See, look, my dog is rooting for you. You guys got this. All right, cool. So basically you have h of a, which is basically if we put in, instead of x, for where x is, we're going to put in a, we have 4a minus 6. But we also know that this whole thing equals 0. So if it's asking what is a, we're basically solving for a. So 4a minus 6 equals 0. And this is a standard solve your variable kind of problem. You add 6 on both sides. Now you have 4a equals 6. Divide by 4 on both sides. You have a equals 6 over 4 or 3 over 2. Or if it's a multiple choice, you got to be very careful. They might be very, like, I guess you say particular on the possible answer. So you have any of these or 1 and 1/2, right? Cool. Now this next problem right here is a doozy of a problem. Let's see if you guys can get this. The inverse of f, and f, once again, is a set of points, right? You have 1, 1, 2, 3, 3, 4, 4, 1, and 5, 2. Forgot to put this right here, but 5, 2 would be a function if the domain of f is limited to what, right? So here's the thing. Wow, this is a wordy problem, but actually not too bad. You guys got it? Cool. All right, so here we go. Let's look at this. We're talking about the inverse of f. Now, the inverse of f is a little tricky. Usually when we say inverse of something, we are talking about a function. But what it does is that in relation to the original function, it does the opposite. It undoes everything that the original function does, right? So, for example, let's look at this. This is all f. If you put in 1, you get 2. If you put in 2, you get 3. If you put in 3, you get 4. If you put in 4, you get 1. And if you put in 5, you get 2. That's the function, the original function. So, if we're talking about the inverse function, which is usually written like this, right? F to -1. This is not exponent in any way. This is inverse function, right? Of x in this case equals, and just to make it easier to see, we're just going to reverse everything. So, rather than 1, 2, right, we're going to have 2, 1, okay? Rather than 3, 2, we're going to have, what is it? Or 2, 3, we're going to have 3, 2, right? Then 3, 4, we're going to have 4, 3. Then instead of 4, 1, we're going to have 1, 4. So you're basically doing the opposite of every one, right? Because remember, it undoes everything that the original function does. So in this case, instead of 5, 2, it's going to be 2, 5. Okay, that's our inverse function right there. Now, it's saying this inverse function would be a function if the domain of f is limited to. Domain is just a complicated word for your input, what you can put in. So these guys right here, all the x is what you put in. The y is usually what you get out of it, right? Your output. So we look at this, okay, and see what would make this a function. And most likely, because it's saying it has to be limited to something, one of these are not going to work. It's going to make it so that this inverse is not a function. So we have 2 gives you 1, 3 gives you 2, 4 gives you 3, 1 gives you 4, and then 2 gives you 5. There's the problem. Notice that you have 2 gives you 5 and 2 gives you 1. So what would you have to limit the domain to be? Well, what it's saying is that which output would you have to basically get rid of, or which input would you have to get rid of so that the output right here is okay? Well, in this case, the one that you have to get rid of is basically anything that include either 2 or 5, because these are the one that's causing you trouble right now, right? It's these two that are in conflict. So if you get rid of one or the other, then the inverse will be a function. So if it's a multiple choice, which I'm hoping it's not, if it is, then you just have to make sure that one of those two options are in there. So it's either this guy or this guy that you have to get rid of. Simple as that. All right, let's look at this next one right here. Which of the following is an even function? 1, y equals x. 2, y equals 4. 3, x squared plus y squared equals 1. Now, you guys got it? Cool. All right, so which of the following is an even function? So as you guys can guess, this is based on the definition of odd and even function, not necessarily on the function itself, although that plays a key role. So if we look at this, first and foremost, you got to remember which one is odd and which one's even. The concept of odd and even function is fairly simple. You look at the function itself, and for even function, x, whatever you put in for x, let's just say whatever you plug that in, it should be the same as if you plug in the negative version. Okay? The answer itself, the output, should still be the same. Right? Odd is saying that whatever, if you put in a negative number inside the function, the end result must be the entirely negative version of if you put a positive number in it. So how do I show that? Basically, for example, without really giving it away too much, is, let's look at this, right? Is this even or odd? Well, basically, if I put in 1 for x, y equals 1. If I put in negative 1 for x, y equals negative 1. So that's what I want you guys to focus on. So my input, if I put in f of x, f of 1, I get 1. If I put in f of negative 1, I get negative 1, right? So, is this odd or even? That's quite simple, right? Positive version is positive. Negative version, negative, right? This right here, this negative input resulting in this negative output of what would be the positive version is what makes something an odd function. So this is odd, which is not what we want because we're only looking for even function. Well, this one right here, quite simple. If I put in any number, let's just say if I put in, well, let's just use 1 again. F of 1, I get 4. F of negative 1, I still get 4. Right? And that's the same for whatever number I decide to put it, because guess what? It's just always going to equal 4. So in this case, actually, it would be an even function because I put in a positive version of a number and a negative version of a number, and they're still equal. That's by definition an even function. Now, this last one I really like. If you follow strictly, it's going to be an even, but it's not a function, right? The reason for that is because if you recognize this from a previous video, this is an equation of a circle. Here's a circle right here. Bad drawing of a circle. If we put it on a coordinate plane and we look at it, right? Notice that for single input, we can have potentially 2 outputs, right? If I choose 0, well, this one is supposed to be centered, but basically you have the top and the bottom possible points, right? If I put any of them, there's always the top and bottom possible points. That means there's 2 possible output for every input I put. So even if this follows the definition of even, this in itself is not a function. So this is not something you should consider. Simple as that. And the only reason for that is because it's saying an even function. If it just says even without saying function in any way, then you can consider 3 as well. Alright, so unless I miscounted, which would be very embarrassing for me, I believe this is the final problem for this video. Is the following even or odd? So once again, it plays on the definition of even and odd, right? So let's look at it. Y equals x cubed minus 1, y equals x squared minus 1. And then the last one, you have this set of points 1, 2, 3, 8, negative 1, 2, 0, 3, and negative 3, 8. Now, here's the thing. If you watch my previous video on basically guessing polynomials, you can immediately figure out which one's even and odd because there's a little trick to it. If you haven't seen it, well, check it out. So here, if the exponent here is even, most likely it's going to be even. If the exponent's odd, most likely it's going to be odd. Are there special cases? Yes. But most of the time, that's a good surefire way to go. You can always test it if you want, but we can just go with that. Since here we have the exponent is going to be 3, a good guess is that this is going to be odd. Now here we have an exponent that is even, right? 2. So a good guess is this whole thing is going to be even. Okay. Now this last one is a little confusing. Basically, we have inputs and we have outputs. Once again, it's quite simple. So we look at this. 1, 2, and then we have negative 1, 2. Okay. That seems interesting. 3, 8, and we have negative 3, 8. Even more interesting. Then we have 0, 3. Is it odd or even? Neither. Now, that would be the conclusion of this problem, but I actually want to point out something very interestingly. If we got rid of this right here, right, ignoring that, it never existed, and we just look at these other points, actually, this ends up being something. We have the positive and a negative version. When we input it, we get the same results. We have the positive and a negative version. When we input it, we get the same result. So, if this wasn't here to just screw everything up, this would tentatively be an even function, right? It's plain and simple. So that's pretty cool. So just hopefully this clarifies at least even, right? And this one at least intuitively odd and even. So we reached the end of this video, and once again, it wasn't meant to teach you guys anything new. It was meant to just go over problems, standardized test kind of questions for you guys to see. Of course, the topic itself is all on functions, so it's a little easier. There are several key components, and the best way to realize is that it covers extensively definition function. Do you know the definition? Can you use it in your favor when you see it? And of course, they have the concept of domain and range and how it relates to a function, the different ways of inputting and outputting stuff in the function, so you understand the different notations, right? If you have f plus g, that's just two functions added together, f minus g, minus, then you have the f of g or g of f, and you know the different orders on how to plug those in, right? And lastly, we have the even and odd functions as well. Is this covering every possible topic of function? No. But apparently those are the more generalized and usually the go-to topics in relation to function in a standardized test. So once again, this video, if you've seen all the answers and how to do them, great. But more importantly, question yourself. Can you answer the questions without really going through what I went through? Can you explain why some of them are incorrect, right? It doesn't, I guess you could say, meet the requirement of the question itself, right? Only when you truly understand those in relation to the subcategories, definition, domain, range, all that stuff, will you truly understand and get a better grasp at function. So hopefully this helps a little bit. Thank you for watching. It might be a long video, I'm not sure, but thank you for sticking around anyways. See you in the next one.